Hello everyone, in this video we will talk about deep reinforcement learning. So what is deep reinforcement learning? It is just a subfield of machine learning that uses special algorithms, neural networks. So what is the framework of reinforcement learning? Firstly, we have agent, as you can see in this graph, and action, environment, state, and reward. So what is the agent? It is just the player in the game. So what is the action? It is any kind of action that the player can take in the environment. What is the environment? It is just the game or the place that the player is available in. So if the player do any kind of action in the environment, so the environment will give this agent the state, which is the new environment after taking that action, and the reward, which might be positive or negative depending on the action or the effectiveness of the action in that environment. Now, what is actually the agent? Here in deep reinforcement learning, it is just a neural network. What is the neural network? It is just a function that has many parameters or adjustable parameters. These parameters, we call them weights, and we will try to adjust them to solve some kind of task or to make the agent able to win in this game. Hi everyone, in this video we'll talk about policy, value function, action, state, function. Firstly, what is the policy? It is just the brain of the agent. So let's say that our agent wants to take an action. In this case, the policy will decide which action to take. It will try to take the action that will give the agent more rewards. That's the policy. And we call it pi. Now, what is value function? Value function is just set a value to each state. Let's say that our agent in specific state and follow specific policy, and let's say this policy is pi 1. And we will compute the value of this state using this equation here. As you can see here, firstly we are in state S and follow policy pi. So we will do many actions or we will do many steps until the end of the episode or the game, and we will get reward after each step. And from R1 to Rn, and we put it weight to each reward just to focus on the most recent reward. And after doing all these calculations, we will get the value of this state. It just means that what is the expected reward when our agent in this state and follow this policy. Now, what is action state function? This function just tells us what the expected reward when I'm in this state and I will do this action or this action or this action like this. Let's say that I'm in this state and I want to move in this direction. So the action state function will give me what is the expected reward if I will move in this direction. That's it. It's easy actually. Now, what is Q learning? It is just we want from our neural network or our agent just to expect what is the expected reward for any state action pair. Hi everyone, in this video we'll talk about the neural networks. So what is the neural network? It is just a function that will take input and return output. So what type of input? The input might be vector or array. So let's say it is vector right here. Okay, so this vector will have many elements, real numbers. Let's say we have n number of elements in this vector. We will pass these elements or this vector through our neural network and we will get another vector as result from this neural network. So what is inside this neural network? We have many layers inside this neural network. What is inside each layer? Okay, each layer will take input, like in this case we have vector with n number of elements. We will pass these elements through this layer. So this layer, it is just array of many elements, array that have many elements. Each element, we call it weight. So this weight, we will try to adjust it to make this layer able to recognize many things inside this vector. So the shape of this array will be equal to the first dimension is the same as the number of input elements, while the second dimension, which is m in this case, it is just the number of nodes of this layer, because each layer has many nodes. After that, we will pass the result from the layer through activation function. It is very important to put activation function after each layer, just to make this neural network able to learn non-linear relationship. We have also another type of layer, which we call it recurrent layer. This layer will take the output of it and concatenate it with the input as well. So the new output will depend on the input and the previous output. Hi everyone, in this video we'll talk about optimal action state function. Previously we talked about action state function or Q function, and we said if I'm in this state and I want to take any action like moving in this direction, after that I will follow a specific policy like pi1. In this case, this function will give me the expected reward. Now, what is the optimal action state function or optimal Q function? Sometimes we write it Q star. What is this? Let's say that I'm in this state and I want to move in a specific direction, or I want to take specific action like moving in this direction. After that, I will follow the optimal policy. So this function will give me the greatest expected reward. So what is the optimal policy? It is easy. Let's say that we have many policies. So this policy or the optimal policy should be better than all policies, or at least similar to the best policy. As we said before, policy it is just the brain of the agent, so it is just the neural network. Now look at this equation here, which is the optimal action state function or the optimal Q function when the current state is S and we want to take action A. After that we will follow the optimal policy pi star. Okay, so here this optimal action state function equal to, when I'm in state S and I want to take action A, like moving in this direction, in this case I will get some reward, which is R sub t plus 1, which is the first term in this equation. Plus we have the discount factor times, here we will use the optimal policy. Because we don't know the optimal policy, we will use the current policy that we have. What is the current policy that we have? Which is the neural network itself, or the brain of our agent. So now we are in the new stage. Let's call it S dash state, and we have many actions that we can take. So our policy will give us many values depending on our action that we will want to take. So here we will select just the highest value from our policy. Now, this equation is very important when we want to train our neural network, and you will see that. Hi everyone, in this video we will learn how to create our own virtual environment. Firstly, we need to download Anaconda. You just need to click on download to install Anaconda. I installed Anaconda previously, so I will not do it again. And it's very easy to download Anaconda. Now we will open Anaconda prompt from Start menu. Now we will create our virtual environment. We will type conda create -n, and here we will type the name of our virtual environment. And finally, we will specify the Python version that we want to install in our virtual environment, which is in this case 3.8. We will click enter. Here we will type Y and click enter again. So now we created our virtual environment. Let's activate our virtual environment. To activate our environment, firstly we need to type activate, and we should type the name of our environment, which is reinforcement learning. We will click enter, and now we activated our virtual environment. Now we will learn how to install the required packages in our course inside our virtual environment. we will type pip install, and here we will type the name of the package that we want to install. Let's say pandas package. We will click enter to install this package in our virtual environment. Now we will install NumPy package, and we will also install Matplotlib library. Now we will install gem package, so we will type pip install gem, and here we will specify the version of this package, so we will type 0.21.0. Now we will install retro package, and the version of this package is 0.8.0. And there is another thing that we should do with retro package, which is importing the rooms to make the games inside retro package work fine. So let's do it. Firstly, we need to go to the folders of our virtual environment. All virtual environments are available in Anaconda 3 folder. We will open envs folder, and we will open reinforcement learning folder, which represents our virtual environment. Now we will search about retro folder. We will open this folder, and we will open scripts folder, and we will take the path of importpath.py script. We will use this script to import the rooms. Now we will go back to Anaconda prompt, and we will run this script, importpath.py script. We will type Python, and here we will put the path of this script. As we can see here, we have this folder, HC rooms folder. We will import the rooms from this folder. You will find this folder in the resources of this lecture. Inside any one of these folders, we have many rooms. So let's open one of these folders and import the rooms inside it. Let's firstly open A-G folder. Now we will copy the directory of these rooms, and we will put the directory here. Now we will click enter to import the rooms inside this folder. We will do the same thing for the other folders. Now we have another folder, which is rooms folder, and we should also import the rooms inside this folder in the same way. So we will copy the directory of these rooms, and we will put it here to import the rooms. You will find rooms folder and HC rooms folder in the resources of this lecture. Now we will import OpenCV library. So we will type pip install OpenCV Python. Now we will install Pygame and PyMonk. Now we will install Jupyter Notebook. So we will type pip install Jupyter Notebook. Finally, we will install PyTorch package from PyTorch official page. Here we need to specify our operating system, and if we want to use Conda or PIP to install PyTorch. And here, if you don't have NVIDIA GPU in your computer, so you should select CPU. But because we have NVIDIA GPU, so we will select Coda 11.2. Now we will copy this line that we will use to install PyTorch, and we will paste it in Anaconda prompt. Now we installed PyTorch. So now we installed all the packages that we need in our virtual environment. So now where we should write our code, we will type Jupyter Notebook, and we will click enter. Now we will create a new notebook, so we will click on new and we will select Python 3. So now we can write our code in the cells inside our notebook. Let's firstly import NumPy package and Torch package. We will type import and we will type the name of the package that we want to import. So now our virtual environment is ready to use. Thanks for watching. Hi everyone, in this video we'll talk about gem package. This package has many environments inside it. So firstly, how can we load this package? It is easy, we just need to type pip install gem. Now, if we want to select one of these environments, how can we do that? So we just need to type gem.make and we should pass the name of the environment. So in this case, we have an object that represents this environment. How can we get more information about this environment? We just need to type the name of the object dot observation space. So here we will get information about the state or the observation that we get from this environment, like the shape of the state. Sometimes you might see a three-dimensional state, two-dimensional state, one-dimensional state like vector. And if we want to get more information about, let's say, the action space or what kind of actions that we can take in this environment, so we just need to type the name of the object that represents this environment dot action space. So here you will know what type of action that you can take, how many actions that you have in this environment, and sometimes the actions might be continuous or discrete. Like in this case, in this grid world game, we have just 4 actions, up, down, left and right, which is discrete, obviously. And with this game, Bird Angry game, we have a continuous number of actions that we can take, as you can see here. Now, if we want to from the agent inside this environment to do some kind of action, firstly we need to select the action that we want from the agent to take. And to do that, it's easy, we just need to type the name of the object that represents the environment dot action space dot sample. So here we will take, or we will get random action. Now we will use a step method to make the agent take that action. So we will type the name of the object dot step, and between these two parentheses we will pass the action. Now if we want to display the game, so we will use render method, and this method has just one argument, which is mood argument. So here we will make this argument equal to human. That's it for today. Thanks for watching. Hi everyone, in this video we'll talk about the environment that we will use in our first project, which is a grid world environment. This environment has many items. We have this robot, hole and gold medal and a wall, as you can see here. So we want to from our agent or the robot in this grid world to reach to this gold medal. And if the robot reach to this gold medal, in this case we will give the robot plus 10 reward. While if the robot reach to the hole, as you can see here, in this case we will give the robot minus 10 reward. While the rest states, for the rest states, we will give the robot minus 1. That's it for today. Thanks for watching. Hi everyone, in this video we will start working on our project. Now, firstly, we should import all the required packages in this project, like, firstly, we should import torch and time, and we should import, let's say, OpenCV, CV2, and Matplotlib as PLT, and of course gem library. Now let's talk about the environment, the grid world environment that we will use in this project. Actually, I made my own environment, custom environment. I didn't use the environments that are available in Gem Package, but I used Gem Package to create my own custom environment. So now let's work with this environment. Let's see what is inside this environment. So to do that, firstly we should import the script that has the code for this environment, which is grid world game.py script. So let's open this script and see what is inside it. There are many things here. The most important thing that we will use here is grid world class. This class will create the game or the object of the game. So from grid world import, we will use, as we said before, grid world class. So we will import just this class from grid world game script. Okay, now let's create an object for this game, for this grid world game. So we will type env equal to, here we will put the grid world class. Now we have many instructors in grid world class. So firstly, let's set grid world size, which is equal to 4. Here the size of the grid will be 4 times 4, as you can see here. And we will set the mode of the game to be static. At this case, all the elements will be at the same place when we initiate the game. That's it. Now we created the environment. So here the environment object, or the object that represents this game. So now let's check this environment. Let's see what is inside this environment. So firstly, let's try to use env dot, let's say observation space. Okay, here we have the observation space. It is just an array, as you can see here. This array, the minimum number in this array is 0, and the maximum number in this array is 1. The shape of the state is, as you can see here, it is 4 times 4 times 4. It is a 3-dimensional array. Now let's check the action space for this environment, which is for discrete. We have just 4 actions that we can take in this environment: up, down, left, and right. That's it. So now let's select random action. So action equal to env dot actions space dot sample Now we will make the agent inside this environment take that action, but before that let's initiate our environment. So env.reset. Now after that env.render, and we will set mode argument to human. After that we will make some delay, which is, so we will use time dot sleep, okay, like this. And after that we will close the environment. Now let's see the game. As you can see here, we have this agent, this robot, this hall, this gold medal, and this wall. And this grid is 4 times 4, as you can see here. Now let's take the action and see. So we will type env.step, and we will pass the action, and we will display the game. Now, as you can see here, this agent moved down to this place here. So now the agent in this place. So it's easy to control this agent. Now we have 4 actions, as we said before. So the actions that we can take are left, right, up, down. So when we want to move left, so we will pass 0 to step method, while if we want to move right, we will pass 1 to step method. If we want to move up, so we will pass 2. If we want to move down, so we will pass 3. So from now we will use this dictionary to make the movements like this: game.step, actions, open these brackets, and we will pass the actions that we want to take, which is left. At this case, this will be equal to 0, so we will pass 0 to step method, so the agent will move in this direction. Hi everyone, in this video we will learn how to build our own neural network. This neural network will have 3 layers, and as you can see here is the first layer, which is linear layer. This layer has many nodes, let's say around 150 nodes, and this layer expects that the input to it should be one-dimensional array. Now let's talk about the input to our neural network. As we said before, the input to our neural network, or the input to the policy, should be the state that we will get from the environment. In this case, grid world environment will give us 3-dimensional state. As you can see here, this state is just 3-dimensional array. We have width, height, and depth. As you know, we have rows and columns in grid world game. So the width is just the number of columns in this grid, while the height dimension, it is just the number of rows in this grid world game. But what is depth dimension? As we said previously, that in this grid world environment we have many items: agent, a wall, a hole, and a gold needle. And to make our neural network able to distinguish between these items, we should put each one of these items in its own 2-dimensional array. So now we have 4 of these 2-dimensional arrays, and we will gather all of them and put them along a new dimension, which is channel dimension or depth dimension. But here we have linear layer. This layer expects that the input should be 1-dimensional array. In this case, we will flatten this 3-dimensional array into just 1 dimension, and the length of this dimension will be equal to the number of rows of this array times the number of columns times the length of the depth dimension, okay, which is in this case around 64 elements in this 1-dimensional array, or in this vector. Now we can pass it through this layer. The output of this layer, we will apply any activation function like ReLU activation function on it. After that, we will pass it through another linear layer. This layer, let's say, that has around 100 nodes, and it will give us a new output. This new output, we will pass it through another ReLU activation function, and after that, we have the last layer. We will pass these outputs through the last layer, which is the output layer. We call it the output layer. So why this layer, or this output layer, has just 4 nodes? Because this neural network will work as a Q function, and the Q function will give us many Q values. Each one of these Q values will related with a specific action that we can take. We have many actions in this environment. We have around 4 actions: up, down, left, and right. So we should have 4 nodes in our output layer. And here we should not put any activation function, or we should not put ReLU activation function, because this activation function will cut the negative values, and the Q values might be positive or negative numbers. We can't remove the negative numbers from the Q values. So here we will just put the linear layer without any activation function. Now firstly, let's try to build our neural network. So firstly, we will create neural network class. So we will call this class net class, like this, open a parenthesis. Here we will pass torch.nn.module. So here we inherited modular class from PyTorch package to net class that we will use just to use the capabilities of PyTorch in net class. Okay. Now in this class we have two methods. The first one is initialization method, which will take the following arguments. The first one is input shape, the shape of the input, and the second one is the output shape, like this. Now here we will create the layers. The first layer, which is self.linear one layer, which is equal to here we will create linear layer. So we will type torch.nn.linear. Here we should pass many things. The first one is the dimension of the input, which is the input shape actually, or the number of elements that are available in the input vector, okay, which is input shape, and the output from this layer, or the number of nodes of this layer. The number of nodes in this layer, let's say around 150 nodes. Okay. Now we will create second layer, which is also linear layer. So self.linear 2 equal to torch.nn.linear, and here linear 2 will take the outputs from linear 1 layer. So the shape of the output from linear 1 layer equal to the number of nodes, which is 150. So we will type 150, and this layer will have around 100 nodes, and the last layer, which is self.linear 3, like this, which is equal to torch.nn.linear, and we will pass the number of inputs to this layer, which is 100, and the number of nodes for this layer. This layer, it is the output layer, so the number of nodes of this layer equal to the number of the outputs that we want, which is 4, because we have 4 actions. So this neural network will give us 4 values. Okay. Now the last layer that we will define is activation layer. So self.activation, which is equal to torch.nn.ReLU activation function. Now we will define forward method. Open parenthesis, self, comma. Here, this method will take the inputs, sometimes one state or many states, like this. And here we will connect these layers that we have. Firstly, x equal to, here we will pass the input through this self.linear 1 layer, and the output from this linear layer we will pass it through activation function, as we said before. So we will use this activation function here. and we will pass the output from linear layer 1, which is this, to this activation layer in this case. So the output from the activation layer, we will pass it through linear 2 layer like this, and the output from linear layer 2, we will pass it through the activation function, ReLU activation function again. Finally, the output here, we will pass it through the final layer or the output layer. So we will type x equal to self, that's linear layer 3, like this. Open the parentheses, and here we will pass the input, which is this one here. Finally, we don't need to put any activation function here, because the final layer, we need from the final layer to return negative and positive numbers. So we can't put any activation function, because ReLU activation function here will cut the negative numbers. But sometimes the Q values that we want from the neural network might be negative numbers or positive numbers. So we will not put any kind of activation here, and we will return the output. So here we have net class. Now we will create network object from this class. So we will call it agent or policy as you want, which is equal to net. Here now we should know what is the input shape and what is the output shape. So firstly, as we said before, the grid size here is 4. So let's make variable here, which is a grid size, which is equal to 4. Okay? Now we have the grid size in this variable, grid size variable. So now what is the shape of the state? Here it is the shape of the state, which is 4 times 4 times 4, which is 3-dimensional state. The state is a 3-dimensional array. Now, here in this network, the input should be just 1-dimensional input, or each state has just 1 dimension. But here we have 3 dimensions. So we should convert all these dimensions into 1 dimension. So the length of the new dimension will be 4 times 4 times 4, or in other words, grid size times grid size times grid size. And let's do that. So input shape will be equal grid size to the power 3. Now we will pass the input shape to our network class. And what is the output shape? It is same as the number of actions that we have. Here we have around 4 actions. So output shape will be equal to the number of the actions that we have. And we will pass the output shape to net class. Now we have our agent, okay, or our network. That's good. Hi everyone, in this video we will talk about the training steps. How can we train our neural network? How can we update the weights inside our neural network to make our neural network good in this environment, or to make the neural network able to win in this environment? It's easy. Here we have 2 things. The first one is the loss function, and the second one is the optimizer. The loss function is just a function that we can use to know if our model is good or if our neural network is good in this task or not. So we have many loss functions. How can we choose the best one to our task? Because the last layer in our neural network don't have any activation function, or the output of the last layer, it is just the output from this linear layer without applying any activation function. At this case, we will use these loss functions that related with the regression tasks. like MSE, RMSE, MAE, and something like that. So here we will use MSE loss function, and actually PyTorch package will give us this loss function so that we can use it easily. Now this loss function will take two things, the targets and the predictions from our neural network. So now we know how to get the predictions from our neural network. We just need to pass the state through our neural network's layers. After that, we will get the predictions from the output layer. So how can we get the target for any sample or any state? It's easy. We will use the optimal Q function that we discussed previously. Here the output of this optimal Q function will be the target that we will use to train our neural network. So the first term in this equation is the reward that we will get after taking a specific action. When we are in state S and taking a specific action, we will get a reward, which is this term here, plus the discount factor, which is most of the time 0.9, times the maximum value of the optimal Q function when you are in state S dash. Here we will imagine that our neural network will be the optimal Q function when we will apply S dash state or the new state that we have. In this case, we will get many Q values and we will take just the largest one here. Now we have the targets and the predictions. As we said before, there are many Q values in the prediction or the prediction of our neural network. We have 4 Q values. In this case, which one we should take and update, or which one we should make it closer to the target? In this case, we will take the Q value that related with the action that we took when we was in state S, like when we are in this state and take a specific action, which is action A, and after that we move to the state S dash. So we will take the Q value that related with this action. Now we have the value of the loss function, which represent the difference between the targets and the predictions of our neural network. Now PyTorch will give us the gradients. The optimizer will use these gradients to update the weights of our neural network to reduce the difference between the targets and the predictions of our neural network, or in other words, to reduce the value of the loss function. Hi everyone, now we will talk about such important topic in reinforcement learning, which is exploration and exploitation. Firstly, what is exploration? It means that we will allow to our agent to discover the environment by taking random actions. Here at the beginning of training, our neural network not good at making decisions. So we will take random actions and update our neural network based on these random actions, just to make our neural network able to discover the new states and to discover the environment. And gradually we will reduce the percentage of exploration and we will increase the percentage of exploitation. So what exploitation means? It means that we will use our neural network to take actions, or we will depend more on our neural network to take the actions, and we will reduce the percentage of taking random actions for discovering the area, because now our neural network better than what it was at the beginning of a training. Now we will try to train this agent or this neural network. How can we do that? Firstly, let's create the loop, training loop. So we will write for, let's say, I in. Here we will specify the number of episodes that we want to train our agent for. Let's type episodes equal to, let's say, 3,000, like this. So we will train our agent for 3,000 episodes. So here, firstly, we will create the environment, like what we did before. And after that, we will take the state, the initial state of the game. So we will type state equal to or let's call it state 1 equal to game.state. So now we have the state, the initial state of the game. Now let's look what is inside this state 1. As you can see here, it is just NumPy array. Let's see the shape of this. Okay, 4 times 4 times 4, 3-dimensional array. Now we should pre-process the state before passing it through our neural network, because as we said before, our neural network expect that the input state should be 1-dimensional input, or each sample has just 1 dimension. So let's create pre-process state function. This function will take 3 arguments. The first one is the state, the second one is the input shape, the last one is add noise, which is Boolean variable equal to false. Now let's change or process this state. Firstly, it is good practice to add small noise to your state before passing it through your neural network to avoid overfitting situation. What is overfitting? It is just the situation where your neural network worked good with your training data, but it worked bad with your test data. Okay, so we will type add noise equal to true. In this case, we will add noise to this state. So firstly, we will reshape the state. So we will type state equal to state dot reshape based on the input shape. Okay, we will pass the input shape to this pre-processed state, this shape that our model will expect for each state, and we will reshape the state based on that input shape, and after that we will add the noise. Now as you can see here, we created this array that has random numbers, and the shape of this array same as the new shape of the state, which is input shape, as you can see here. Now we added this noise to this state. Now if we don't want to add this noise, so at this case we will just reshape the state like this. Finally we will return the state like this. So now let's check this function if it works. We have state 1 actually. This is state 1. We will pass it through this pre-process state function like this, and we will pass the shape that we want, or the shape that our neural network expect. Now we will pass the shape that our neural network expect. Here we have 2 dimensions. The first dimension, which is the dimensions that related with the number of samples, or this dimension represent the number of samples that you want to pass it through your neural network. Sometimes we pass more than just 1 sample. The second dimension, which is the dimension of each sample, which is the input dimension that we created before, like this, the shape of each sample, which is the input shape, this one here. Now we will add noise to the state, so we will make add noise equal to true like this. Okay, let's see the results. Okay, we forgot to put the star here. This star we use it to unpack the input shape tuple. Okay, now it works properly like this. So now we pre-processed the state. So let's put it in this loop, training loop. So we will type first state 1 equal to, we will put this one here. Now that's okay. So what we should do next, actually, now we should convert this stage 1 array, NumPy array, into PyTorch tensor, because we want to pass this array through PyTorch network. Okay, actually here we should type range like this. Okay, range. So to make this one work here like this, that's it. We will delete this print. Now what we will do, actually, now we will start the game. So we will create a variable, we will call it gate, which is equal to 1 firstly. This gate variable will tell us if the game end or not. Okay, we will create while loop here. This while loop will work if gate equal to 1. Otherwise, we will go out from this while loop. Firstly, we should pass this array through our neural network. The object that represents our neural network is agent object. So we should put it here, open parenthesis, and here we will pass the state. Okay, let's get the results, which is the Q values actually for each action. So it means that when we are in a state S1, so we will have a special value, Q value, for each action. So this Q value, it is just a tensor that has 4 values, which represent the Q value for each action that our neural network returned for us. Okay, now what we will do, actually, let's firstly see what is inside this Q value. Oh, it is tensor with 4 numbers. Okay, 4 elements. Now we'll convert this Q value, which is PyTorch tensor, into NumPy array, which is easy actually. So to do that, firstly we should type qval numpy equal to, here we will type qval dot detach dot numpy like this. So as you can see here, we converted these PyTorch tensors into NumPy arrays. Now we should get the action that we want to take. So we will create another function here. Let's call it getAction function. Open parenthesis. This function will have many arguments. The first one, Q value, the second one, the number of actions, the last one, epsilon, that we will talk about it later. Now we have a very important concept, which is the exploitation and exploration. Exploitation means that we will use our neural network to get the action, while the explorations means that we will take random action just to make our neural network able to discover new states. And the argument that will control the percent of the exploitations and the explorations is this epsilon argument. Okay, so now as you can see here, if the epsilon is greater than random number between 0 and 1, at this case we will get random action. Okay, so we will use mp.random.rand integer from 0 to 4, and we will get random action. It might be 0 or 1 or 2 or 3. So this part is for exploration. At this case, we will make our neural network able to find new states, discover new things, while if this random number greater than epsilon. At this case, we will use our neural network to get the action. Actually, we will use the action with the highest Q value. So we will use mp.argmax and we will pass this Q value here, and we will work on the second dimension or column dimension. In this case, we will get the actions with the highest Q values. Okay, now we will check this this function. Here we will pass Q val numpy in this case. So action equal to, here we will type the name of the function that we created, which is get action function, and we will put it here, open a parenthesis. Here we will pass Q val numpy, and we will pass the number of actions that we have, which is the length of actions, and epsilon. Firstly, let's put epsilon equal to 1, which means that at the beginning of the training we will do just exploration. So now we will pass this epsilon here. So we will get the action that we want from our agent to take. Now let's see if it works. We will pass Q val numpy, and let's see if it works. Yes, it worked. No problem. So now what we will do here, we will make the agent take this action. So we will type game.step, and we will pass the action that we want from our agent to take. And here we will get many things like state 2, the new state, or state dash as you want, and the reward that the environment gave to our agent. And we have also this one here done, which is tell us if the episode is over or not, or if the game is over or not. That's it. Now we should pre-process state 2. We will use pre-process state, as you can see here, but this time for state 2, like this. Previously we talked about Bellman equation. Now we will use this equation to create the target. Okay? So firstly we will extract the Q values when we are at state 2. Let's do it. So here, firstly we will type with torch.noGradient. This thing here, tell PyTorch that we don't want to take or compute any gradients for anything inside with torch.noGradient. Now we will convert state 2 to PyTorch, like what we did previously, like this, but now for state 2, so that we can pass it through our neural network. Now what we will do, actually, we will pass state 2 through our neural network to get the Q values when we are in state 2. Okay? Here we are trying to implement Bellman equation to get the target so that we can use it during training. Here we will type with torch.noGradient. This line will tell PyTorch that we don't want to compute any gradient for this thing here. So here we don't want to take any gradient because we don't want to take any space from memory for something that we don't need. So now we have the Q values for these 4 actions when we are in state 2. Now let's make a create target class. Okay, and we will use this class to implement Bellman equation. As you can see here, we have this simple class, target maker class. This class has 2 methods, initialization method and call method. Okay, the first method here, we have just one thing inside it, which is self.terminal rewards, which is equal to terminal rewards. This function or this method will take terminal rewards. So for example, if the agent reached to the gold medal, in this case we will give the agent plus 10, while if the agent reached to the hole, in this case we will give the agent minus 10 reward. So we will pass these rewards or terminal rewards to this method, and we will store it as self.terminal rewards. The second method, which is call method, this method will take current reward, gamma, and max q. Okay, and here we will check if the current reward not available in self.terminal rewards. At this case, we will use Bellman equation to compute the target y. So y equal to the current reward, as you can see in this equation, plus gamma. Actually, we will pass gamma as well, or discount factor, which is 0.9 here, times the maximum q value, which is this one that we computed previously. While if the current reward is in self.terminal rewards, at this case we will make the current reward, at this case we will make the current reward equal to the target y. So now we will convert y into PyTorch tensor and we will return the target. Now we should create an object for this target maker class. Let's do it here. So firstly we should set gamma equal to 0.9 like this, or discount factor. Now we have create target object equal to, here we have target maker class like this, open parenthesis, and here we should pass the terminal rewards. So what is the terminal rewards that we have in this game? So we should type terminal rewards equal to minus 10 comma plus 10. That's it. So we will pass this terminal rewards through this target maker. Now we created the object of target maker. We can use it to obtain the target that we will use during the training. Okay, so let's do it. So y, or the target, equal to create target, and here we will pass a few things. As we said before, we will pass current reward, gamma, and maximum q. So what is the current reward here? It is this one here, the current reward. So we will pass it here, comma. What we have also is gamma, so we should pass gamma value, and also we have maximum q, which is this one here. We will pass it here as well. Now as you can see here, it works. Now we know what is the target value when we take action A. So now we should extract the prediction of our neural network for this action, or the q value for this action. We have all q values for all the actions that we have, so we will return just the q value for this action, or for this specific action. So we will type qval dot squeeze, open square brackets, and here we will pass the action. Let's say that we that our agent take action 0. At this case, this is the value or q value of action 0. So here x, or the prediction, will equal to this value, and we have the target value as well. So we will update this value, or we will update our neural network to make this value closer to the target y. That's it. So now we need loss function that compute the difference between the target and the prediction of our neural network. Now let's make this loss function. As you can see here, loss function equal to torch.nn.mse loss. Because the last layer of our neural network don't have any activation function, in this case we will use MSE loss function, which most of the time we use it for regression tasks. Okay? Now, so loss function, open a parenthesis here, we will write the target and the prediction. Here we will pass the prediction, which is x, and the target, which is y. So here we will compute the difference between x and y, the prediction and the target. Now, if we know the loss, what to do to update our neural network's weights? It's easy. We will use the optimizer. As you can see here, optimizer equal to torch.optimizer.atom, and here we should pass the parameters of our agent, or the weights of our neural network, and we should pass the learning rate. So let's set the learning rate, which is, let's say, 0.001, like this. It is important to make our optimizer work. Now let's use our optimizer. Firstly, as we said before, we will use the gradients to update our weights, or actually the optimizer will use the gradients to update the weights. So firstly, we will make all the gradients that are available in the optimizer equal to 0. To do that, we will type optimizer.0gradient. So now the optimizer will remove any previous gradients from previous steps and will use just the new gradients. So to compute the gradients, we just want to type loss dots backward. So here we will compute the new gradients for the system. Now to update all the weights in our neural network, we should type optimizer.step. At this case, the optimizer will update all the weights to reduce the value of loss, actually. Now we are in state 2, so state 1 will be equal to state 2. Okay? Here I want to record the losses, so I will create losses list, and we will store this loss, or the loss of this step, in this losses list. Now we will check if the game is over or not. Now we will check if the episode is end. At this case, we will make gate variable equal to 0. So we will go out from this loop and we will do a new game. And here we will reduce epsilon variable, because when we go more and more in the training, at this case we will try to increase the percentage of exploitations, or we want from the model to make the actions more than the explorations, or more than take random actions. So we will reduce it by this amount, which is the 1 divided by the number of epochs, which is around, or number of episodes, same thing here, which is around 300 or 3000. At this case, we will get a new epsilon, or we will reduce the value of epsilon to increase the exploitation, or to increase the probability that we get the action from the model, not randomly. And we have simple problem here, and get action. Here this line will give us an array, not integer. At this case, you can put 0 here just to return integer. Let's type game.render. Okay, and actually we should put at the end of the game game.close, like this. As you can see here, the agent or the robot now trying to find the best way to the gold medal. Now the training process is end, so let's test our agent. Firstly, let's copy all these things. Okay, so here we just want to test the model. We don't want to train it. So all these things we will not we don't need them. Then here, this get action, we don't need to take random action at this case. So here we will just get the action from our neural network. So now, as you can see here, our robot know its way to the gold medal. Hi everyone, in this video we will learn how to improve the training process to make our neural network better at its task. In the previous video, we trained our neural network on just one sample each time. So PyTorch will produce the gradients based on just one sample, and these gradients will be noisy. And because of that, we will use these gradients to update the weights of our neural network, so the training process will be noisy as well. To solve this problem, we will train our neural network on many samples each time. So PyTorch, in this case, will compute gradients for the first sample, the second sample, etc. And after that, we will average all these gradients, and the optimizer will use them to update the weights of our neural network. To do that, let's say that we have this memory here. We will fill this memory with many experiences that we will get from the environment, or many samples that we will get from the environment. After that, we will get random batch from this memory, and we will pass it through our neural network, get the predictions, and as you know, we have the targets for each experience, so we will get the loss value. After that, PyTorch will compute the gradients for each sample, or will compute the gradients based on each sample or each experience, and we will get the average, or PyTorch will compute the average gradients. After that, the optimizer will use these gradients to update the weights of our neural network. Now we will make Grid World game more difficult than what it was before, and we will put each item randomly in the grid each time that we initiate the game or the environment. And we will test this approach and if it is good or not compared to the previous approach on this task. Let's do it. Hi everyone, in this video we will learn how to train our neural network on a batch of samples each time or at each step. Firstly, we will use our previous code, okay? So we will change this code a little bit just to make it work with a batch of samples each time rather than just one sample each time. So let's put our code in this place here, in this cell. Firstly, we will import deck class from collections package. We will use this class to create our memory or replay buffer that we will use to store the samples or the experiences. Now we will create memory size variable and we will make it equal to 5000. This variable will specify the number of experiences that our replay buffer can take. After that, we have batch size. Here we created batch size variable and we will make it equal to 200. This variable will specify the number of samples that we will use to update our neural network at each step. So we will take around 200 experiences from our replay buffer and use them to update our neural network at each step or each time. Now we will create the replay buffer that we will use to store the experiences. So replay equal to DAC, open parenthesis, max length equal to memory size. So now we created a memory that can take around 5,000 experiences. Now we will create device variable which is equal to CODA here. So here we will specify the device that we will use to train our neural network. And here if you set this variable to CODA, in this case you will use your GPU to train your neural network, which will make the training process very fast. So here we will create our agent. So agent equal to meta-class, open parenthesis, input shape, comma, output shape, to device. So here we will send our neural network to GPU, to our GPU, to make the computations in that GPU. So in this case we can use our GPU to train our neural network or our agent. Now we will change the game environment a little bit. Now we will change static to random. By doing this, we will put the items of our environment at random places each time that we initiate our environment. So in this case, the game now is much harder than what it was before. Now we should create the experience. As you can see here, each experience, it is just a tuple, and this tuple should have the state, the current state, the action, the reward that we got from our environment, the new state or state 2, and done. If it is true, so it is the end of the game. And we will put this experience into our replay buffer. So we will type replay.append, open parenthesis, and here we will put our experience. So here we added our experience to our replay buffer. Now we will add this condition here. We will check the length of our replay buffer. So at least if it has around 200 experiences, so that we can use them to train our neural network, okay? We will remove all these things here, okay? So now let's put this one here, this line here. As you can see here, we will create special function that we will call it getBatch function. This function will take our replay buffer and the batch size, which is 200 at this case, and the device that we use to train our neural network. At this case, it is our GPU. This function will give us state1 batch. So this batch will have the current state for each experience. And we have action batch, and we will get action batch, and we will get reward batch, and we will get state 2 batch, which is a batch of the next state for each experience. And finally we will get done batch. This batch will tell us if the game is end or not for each experience. So now let's create this getBatch function. Let's put this function here, okay? GetBatch function. As we said before, it will take replay buffer, our replay buffer, the batch size, and device, which is by default equal to CPU. But now we will change it to CODA or GPU. Here we will take mini batch, or we will take random batch from our replay buffer using random.sample, and we will pass our replay buffer, and we will pass the size of each batch, which is 200 at this case. So now we have our batch. We will extract the current state batch, action batch, reward batch, and state 2 batch. As you can see here, we have this list, and we will type the following: S1, which is the current state for any experience, 4, open parenthesis, we will get this tuple from our mini batch, which has the current state for any experience, comma, the action, comma, reward, comma, the next state, comma, done. Okay, in mini batch. So we will loop through each experience and we will take just the current state for each experience. So now we have the current state for each experience and we will concatenate all these current states using torch.concatenate. So now we have PyTorch tensor that has all the current states for each experience. Okay, and we will send this TensorFlow tensor to our GPU or our device, and we will extract action batch as well. So torch.tensor, firstly we will extract each experience from our mini batch, and we will just take the action that related with any experience. So now we have a list of actions that related with each experience. And you should know that we used concatenate because each current state, it is just an array. So we should use this method to join them together. But here 8 is just a number, not array. So we can just use torch.tensor or convert them directly into torch tensor. And we will type .long to convert the type of our tensor to integer, because we will use these actions as indices, where we will use them to specify which nodes that we will get our Q values from, the Q values that we will use to update our neural network as we did previously. Now we will get reward batch, which is equal to torch.tensor, and here we will loop through each experience and we will just extract the reward that related with each experience. And now we have a list of rewards that related with each experience. We will convert them into PyTorch tensor. Finally, we will send it to our GPU. And now we will create state2 batch, which is equal to torch.concatenation, open parenthesis, open square brackets. Here we will just take the next state that are related with each experience. And we will send the result, the PyTorch tensor that we will get, to our GPU. Finally, we will create done batch, which is equal to torch.tensor, open parenthesis, open square brackets. Here we will just take done, variable that are related with each experience, and we will send them to our device. Finally, we will return all these things, as we can see here. So here we got a batch, a random batch from our replay buffer that we can use to update our neural network or to train our neural network. Now let's continue. Firstly, we will pass our state1 batch tensor to our agent or our neural network, and we will get the Q values that are related with each experience. Now we will compute the Q values for each next state in this state2 batch, and we will store them in Q2 tensor. Now here we will take the highest Q values from our Q2 tensor. Because this tensor is two-dimensional tensor, each row in this tensor represent the Q values that are related with a specific experience. So we will take the highest Q value for each row. So in this case, we will make axis argument equal to 1. And actually, this max method will give you two things. and we will take just the first one, okay, which represent the highest Q value for each experience when we pass the next state that related with each experience through our neural network. So now we have all these things in this max Q tensor. Now we will create a new function that we will call it batch target function. This function will compute the target for each experience in our batch. Firstly, we will pass our reward batch and gamma variable, which is equal to 0.9, and max Q tensor, and finally done batch. Now let's create batch target function. Now as you can see here, our function that we will use to create the targets that are related with each experience, which is define batch target. This function will take reward batch, gamma, max Q, and done batch. Okay, so y equal to reward batch. This batch will have the reward that related with each experience plus open parenthesis gamma times max times open parenthesis 1 minus done batch. So now why we put this term here, 1 minus done batch term, it means the following. As we said before, when done equal to true, it means that this experience is the end of our game. And true, it means 1. So 1 minus 1 equal to 0. When we multiply anything by 0, in this case, the result equal to 0. So you will use just the reward that related with those experiences where done equal to true in done batch. Okay? While if done equal to false, which means it's not the end of the game at this case, so 1 minus 0, which is equal to 1, and when we multiply 1 by these things, so we will use these things to compute the targets for those experiences where done equal to false in done batch tensor. So we will use the highest Q value for the next state for each experience where done equal to false, and we will multiply it with gamma. After that, we will add it with the rewards that related with those experiences where done batch equal to false. So now we have this Y tensor. This tensor has many targets, each one related with a specific experience in our batch. So now we will return this tensor or Y tensor. Okay, now we will get the predictions from our neural network or from our agent. As you know, we have this Q1 tensor. As you know, this tensor will have the Q values for each experience after passing the current state for each experience. So here we will take the Q values that related with the actions that we took for each experience. And here you should know that we might not take the highest Q value for each experience, because sometimes we might take random actions, because here we are using optimal greedy approach to make our neural network able to discover its environment. And we will use gather method, open parenthesis. We will specify the dimension, which is equal to 1. We will work on dimension 1, which is the column dimension. And as we said before, we will use action batch as indices to take the Q values that we will use to update our neural network. So we will type action batch.nSequence dimension 1, because we need to change the number of dimensions in our action batch to be equal to Q1 tensor. And because that we have 2 dimensions in this Q1 tensor, so we should change action batch to 2-dimensional tensor by using nSequence, and we will specify the location of the new dimension, which is dimension equal to 1. So now we have the predicted Q value for each experience based on the action that we took for each experience, and we will store them in X tensor. Finally, we will use our loss function and we will pass the predictions, our predictions and our targets. And we will print the loss each time, as you can see here. And we will clear the output each time as well. And we will add the loss of each step to our losses list. After that, we will update our neural network. Here we will create a special function that we will call it update. Let's create it. Before that, this function will take the loss and the optimizer. Let's put it here. So now, as you can see here, update function. This function will take loss and optimizer as arguments. Firstly, we will initiate our optimizer. After that, we will make packet propagation. So we will type loss.backward. And finally, we will use our optimizer to update the weights of our neural network. So we will type optimizer.step. Okay, that's it. So update method will update the weights of our neural network. And here actually we should send this state 1 to our device, to device like this. And we have another problem here. Can't convert coded 0 device type sensor to NumPy. So we should send it to CPU. After that, we can convert it into NumPy. So let's go back here in this place. We will type CPU like this. And here we should do the same thing with the state 2 actually. We should send it to device. Now, as you can see here, here is the loss each time or at each step. Our agent tried to learn how to win in this game. Now we can draw the losses using Matplotlib library, as you can see here. Here we can see the loss after each step. As we said before, we need to reduce the value of the loss, and that's what we did here actually, as you can see here. Now let's test our agent. We will use the same code that we used in the previous sessions. Okay, let's run this one. Yes, as you can see here, our agent tried to find the gold medal, and it works good. Thanks for watching. Hi everyone, in this video we will create reward metric that we will use to tell us if our agent gets better and better during training or not. As you can see here, this is our reward metric function that it will take 2 arguments. The first one is all rewards list argument. The second one, last n rewards argument, which is equal to 20 by default. The first one, it is just a list. This list has many rewards. Each one of these rewards related with a specific step during a training. The second one, which is last n rewards, this argument will specify how many rewards that we will use from our all rewards list to compute mean reward. What is mean reward? It is just the average reward of the last n rewards in our all rewards list. So here, if the length of all rewards list is greater than the last n rewards, we will compute mean reward using this line here. So numpy.mean, so here we will take the average of all rewards list, open square brackets, minus last n rewards colon. Here we will take the last n rewards in our all rewards list. After that, we will compute the mean for these rewards, and we will store the result in mean reward variable. But if the length of all rewards list is less than last and rewards, in this case we will make mean reward equal to 0. Finally, we will return mean reward variable. And here we will create two lists. The first one, all rewards list, which is empty list firstly, and we will create mean rewards list. Now after each step, we will store the reward that related with this step in our all rewards list. After that, we will compute mean reward value, which is equal to, here we will call reward metric function that we created previously, and we will pass all rewards list and also the last and rewards that we will use to compute our mean reward. So in this case, we will use the last 100 rewards in our all rewards list to compute the average reward or the mean reward. After that, we will store this mean reward in our mean rewards list. Here we will train our agent for around 10,000 episodes. Okay, let's see the result. Here we will use Matplotlib library to visualize our rewards during training. And as you can see here in this graph, the mean reward increased during training. Thanks for watching. Hi everyone, in this video we will learn how to make the training process more stable. Firstly, why our neural network unstable during training? It's easy. Let's say that we have this batch here and we want to pass it through our neural network, so we will get the Q values, and here we want to calculate the target for each sample in this batch. To do that, we will use optimal Q function. And as you can see here in this term will depend on our neural network that we will call it agent neural network. So if we update this neural network, this term will change as well. So the target here will change. So the target here is not constant. It's like dog trying to catch its tail. So the training process will be unstable. So in this case, to solve this problem, we will create a new neural network that we will call it target neural network. To do that, firstly, we will copy this neural network, the agent neural network, and we will put the values, the weights values of the original neural network or agent neural network in our new neural network or on target neural network. So here we will compute the targets using this target neural network. Firstly, we will pass the batch through our agent neural network, get Q values. After that, we will use this target neural network to compute the value of this term in the optimal Q function. So here the target will be constant at this case. And this target neural network, we will update it after a specific number of steps, like 50. So here we will update the weights of the target neural network after each 50 steps. So to update this neural network or target neural network, we will just get the values of the weights of the original neural network or agent neural network and put them in the target neural network. Now let's do that. Hi everyone, in this video we will build target network to make the training process more stable. Let's do it. Firstly, we will copy our previous code and put it here in this cell. Okay. Firstly, we have agent network. Okay. Now let's create target network. As we said before, we should copy our agent network to create our target network. So we will import copy package. Okay, now here's our target network, which is equal to copy.deepCopy, open parenthesis. Here we will pass our agent neural network. So here we made a copy of our agent neural network, which is our target neural network. So now, as we said before, we will use our target neural network to create the targets. Okay? So here, rather than using our agent neural network to get the Q values for each experience after passing the next state for each experience, we will use our target neural network here. And as we said before, we should update our target neural network's weights after specific number of steps or a specific number of episodes, where we will put the weights values of our agent neural network in our target neural network after a specific number of steps. To do that, firstly we need two variables. The first one is K and the second one is synchronize frequency. The first one means the number of steps, or you can change it to the number of episodes. It's up to you. The second one, it is just specify how many steps that it should pass before updating our neural network. And we will use this modular here to do this condition. So after each specific number of steps or specific number of episodes that is specified by synchronized frequency, we will update our target neural network. So firstly, we should extract the weights values of our agent neural network using a state duct. After that, we will pass them in through our load state duct. At this case, we will put the weights values of our agent neural network in our target neural network. Firstly, we should specify the synchronized frequency variable. Let's put it here. Now let's set our synchronized frequency variable to around, let's say, 30 steps. Here we will work based on steps, not episodes, okay? If you want to work based on episodes, you will use I rather than K, where I give you the number of episodes that you reached. So now let's initiate K variable, which is equal to 0 firstly. And we will increase it after each step, okay? So we will increase this variable inside while loop. So K equal to K plus 1, okay? So after each step we will increase K variable by 1. So K here represents the number of steps that we reached. And as you can see here, so we created this variable and this variable. Here we created our target neural network, and also we should put the weights values of our agent neural network in our target neural network initially. To do that, we will just use load state duct, and we will pass the weights values of our agent neural network like this, like what we did previously. Actually, here we should convert this agent neural network and this one here to agent neural network. Now it should work fine. Let's start training process. Here is the results, the mean rewards and the losses after each step. Here I can't see any improvement, so I can change this synchronized frequency. Let's put it 500 and see if the results will be better or not. Now as you can see here, here's the losses during training after each step, which is better than this one here, as you can see here. Thanks for watching.